All right, so this video is going to be a little bit different. I'm going to do it all on Desmos, I think, or try, just because it kind of helps me show you the things that you need to know. What we're going over next, or starting in this video, are quadratic functions. And that sounds all kinds of complicated and things, but actually we've been using quadratic functions. All of the last chapter was quadratic functions. You were factoring quadratic functions. So a quadratic function is any function that has an x squared. Okay, so f of x, if you notice up here, f of x equals x squared. That's the function, f of x equals x squared. This is what, if you remember back to absolute value, which I know was not anyone's favorite topic, absolute value, we had the parent function, which was f of x equals the absolute value of x. And it actually looked similar to this. I'm going to go ahead and put that in, f of x equals, whoops, too many parentheses, f of x equals the absolute value of x. There we go. Okay, same idea, it increases on both sides. And our quadratic function does the same thing, it increases on both sides. Okay, and if you remember, we had something called the vertex form of the absolute value function, and we have the vertex form of the quadratic function as well. The curve, we have a name for this shape that it makes, and it's a parabola. Okay, I'm just kind of going through the vocabulary. All right, so let's look, and I'm going to just type this in generic form. We have what we have of the parent function. We can rewrite it like this: a times x minus h squared plus k. Okay, and this again is very similar to the absolute value function. Each of these, the a, the h, and the k, all have specific things that they do. The h and the k are actually our vertex. So for the first one, there is no h, there is no k, and so our vertex is at 0, 0. So right there at 0, 0. If we add sliders just are something that we can do to kind of adjust things. So I'm going to go ahead and leave a at 1 for now. H I'm going to move down to, I want that at 0. K, I'm going to move that down to 0. Okay, so let's just move these one at a time. We're going to start with A. Notice what happens as A increases. So as I drag A up, it gets closer and closer to the y-axis. If you remember, we had horizontal compression and expansion. Compression means we're moving down towards the x. Oops, too far. And horizontal expansion means we move away from the x faster. Okay, so the higher my a value gets, the closer I'm going to be hugging the y-axis. And then you notice when I went too far and I went negative, my parabola was facing down. Okay, so that's what the a does. The a changes how fast my values go up, or how narrow or wide it is, and then whether or not it's facing up or down. Okay, so that's my a value. My h value, remember x minus h. So notice that when my x value goes up, when my h value goes up, oh, whoops, I zeroed out my a. We need it to be a 1. Okay, so notice that when h goes up, so when h is positive, it moves right, and when h is negative, it moves left. And that makes sense, but also notice that in the actual equation, it's x minus h. Okay, so when h is positive, you're subtracting that number. When h is negative, you're adding that number. Okay, and that's a little counterintuitive. Your h value itself moves like you would think it would. And if you need help like picturing this, just go ahead and plug in a value. So plug in -4 for h, and then graph it and see what it looks like. Okay, but that's what the h value does, is it moves it left and right. Okay, so I'm going to move that back to 0. And then the last one that we have is the k value. And you probably have already figured out, okay, a expands or contracts it, h moves it left or right, so k moves it up and down. Okay, so it moves it up or it moves it down. And it's just the number of spaces that k is. And that's really all there is to the equation. Okay, a is contraction and expansion, h is left, right, and k is up and down.